Thank you very much for the introduction. It's my pleasure to be here today. So first of all, let me share the screen. And so I believe you should be able to see the screen. Let me
We're able to
start the presentation. Let me just minimize this. Okay, so the aim of this session is to, well, the main topic is GenAI, and there's been a lot of hype around generative artificial intelligence. So what I thought at first was to have a very general talk, but then I thought that perhaps I should have introduced some of the technical aspects. So I try to look at both worlds, so to speak. So Gen AI requires extensive background knowledge. It's a very multidisciplinary area. Some of the aspects that are being part of Gen AI, but also in artificial intelligence in general, is based on neuroscience, is based on mathematics, is based on a lot of psychology, in medicine, etc. And it can be also very technical and mathematically focused. So as I said, I'm really aiming for a general discussion, about 40, 50 minutes. So we'll introduce the main concepts related to this topic and also some simple coding. Initially, I wanted to have a more interactive session using Colab, which is a Python-based web-based platform. But some of the models that we would need to load would take minutes, and it could be up to 20 minutes. So I've run all the different commands in advance, and then so I can show you in on the screen. So I won't spend a lot of time on this. I am a professor of computer science, and I have academic and research and development experience. And in particular, I'm interested in artificial intelligence and in the mathematical modeling for decision-making processes, in particular, the automated information extraction from unstructured data. I'm interested in collective behavior, and all these are interconnected. And there are a variety of applications, including data analytics and visualization, but also complex systems and disruptive technology and Industry 4.0, although we're already starting talking about Industry 5.0. So what is artificial intelligence? Let's start from the beginning. So there are a variety of definitions of artificial intelligence. And in order to understand Gen AI, we need to look at them in some details. So in a nutshell, artificial intelligence is the field that so we try to mimic what our brain does so well. So we try to automate the process of understanding videos and images. So that would be computer vision, understanding text, so as NLP or natural language processing, as well as understanding audio signals, speech processing. And there might be some variations, there might be some cross-contamination, but these three are loosely speaking the most important areas that AI technologies and techniques and frameworks focus on. And the aim, and not always, but the general aim is to be able to do so without any predetermined rules. So let's compare what a human would do as opposed to a computer. So when we talk about conventional decision-making processes, so what, as a human developer, I would define all the conditions necessary. So I could come up with a mathematical model. I could come up with a flow chart or a business analysis model. And by looking at some of the data, I would get a set of rules. We try to do the same when it comes to artificial intelligence. So we want, however, the difference here is the computer will automatically define all the conditions necessary. In some cases, we give the computer, the system, a little nudge. So we make sure that some of the rules are in a way pre-coded to initiate the process. And so we can reach the same conclusions by in a much better way. There are some issues that, first of all, in order to get to a good understanding of the problem, we usually need loads of data. But at the same time, the good news is that we're actually in a position of dealing with a lot of data. When a human developer, human modeler deals with a new model, with a new definition of a set of rules, he or she would look at a relatively small, and compared to AI, very small data set. And he or she would go through all the analysis manually. It's something that doesn't happen in AI. Another aspect which is really important, and I will mention that with respect to, for example, GPT and other GenAI techniques that are out there, is the distinction between weak artificial intelligence and strong artificial intelligence. Weak AI is really specific. Think about the old IBM Blue, which actually managed to beat Kasparov playing chess. And so the system was able to understand and to predict the potential moves and assess the likelihood then a specific move would have in terms of success. But it's very specific. If I am teaching a kid, for example, how to play chess, we expect that the kid or any person learning chess will be able to apply the strategic thinking that he or she has acquired by learning chess to other contexts. Weak AI can't do that. It can only play chess, and that's it. So there's no generalization. So for weak AI, we have systems that act like they think. So if you interact with ChatGPT, you really have the impression that you've got somebody behind there that can actually interact. It's almost like interacting with a person, but it's not. It's just pretending in a way. It looks like, but it's not. And you can see that we have a limited amount of range of answers. And for strong AI, we would be able to, we would include the understanding, the perception, having beliefs and judgment and reasoning, intuition, everything else that a system doesn't have at the moment. And there is extensive research on how people actually can make specific decisions effectively by thinking outside the box, by using intuition, by using creativity, something that is not fully developed in weak AI. So, and for the generative artificial intelligence, what we have here, we have the generation bit, which is part of the name. So it's about generating text, images, and other media. And there are a variety of generative models, and they tend to be very data hungry. So they need loads and loads and loads of data. And so by using large quantities of data, then the system will learn specific patterns, specific structures that will imitate the type of the training data set that have been used. So we have images. So when we think about, we think of deep fakes, for example, and other techniques that are related to GenAI. We see that they're based on large sets of images. We also have some text captions included, and we can actually create automatically specific images based on some sort of description. Let me check. I have a question. Oh, okay, yes. I keep an eye on the Q&A icon, should you have any question now. And then we have the related to text. And we have the GenAI related to text. Again, trained on very large data sets. They are capable of information extraction, machine learning translation, and natural language generation. So we can communicate. For example, ChatGPT. We can use a platform to have a conversation, and it's based on large language models. As the name suggests, we have large data sets are used to train the system. And the use of, so we can use the prompts and the replies to create a context for the system. So it really looks, we are talking to a person, to a system that can actually understand. Right. Let's look at this example. So we have, suppose we have say an English-speaking person, but could be any other language, who knows no Chinese. And again, could be another language, completely another language. But just for the sake of simplicity, assume we have this person stuck in a room. This man doesn't understand a word of Chinese. He can only understand English. So he receives some sentences in English and needs to translate to Chinese. What he has a rule ledger. So he has an instruction. He will look it up in his book, and he will have a translation. So the question is this a weak? Of course, we are talking about human, but if we had something similar in an automated way, would it be weak or strong AI? And the question is fairly straightforward. It's weak AI, because the person can't really understand Chinese. All it does is following some rules. So if you have a specific input, then it will look it up in his book and it will find the corresponding translation. But it doesn't have a clue what the symbols mean. It just follows the rules. And so that is actually what happens in the majority, if not all, the artificial intelligence techniques at the moment. But let's look at text in particular. So to understand GenAI, we need to look at the complexity of the language. So we have NLP, which stands for natural language processing. It's been around, it's a discipline, it's been around for decades, but we're still using it. We are still trying to sort some of the problems. They are still giving us a headache. So what is it? So we have unstructured data. So you read in this slide and you can see, you can extract some meaning. But if you think of it, all we have symbols, we have dots on a screen, nothing else. But then you are able to look at letters, to consider words, and then words together will have a structured data set, something that we can actually use to get some meaning out of it. And so we have, for example, scientific papers, doctors' reports, product reviews, blogs, tweets, Facebook posts, and so on and so forth. So what we want to do, we want to get out of it, what we want to get out of it is the extraction of concepts, for example, whether I'm talking about a person, whether I'm talking about a specific concept, but also entity recognition. Am I talking about an organization? Am I talking about a country? Am I talking about a specific subset of a population? We also want to identify a document. When I read a book, I understand, if I have some knowledge about the specific literature, I understand the context. I understand when the book was written, and I can understand the style, but I also understand the sentiment, the opinion related to it, and that is the sentiment analysis. But I'm also able to summarize the document. I'm also able to summarize what the book is telling me. So that is so, and on the right-hand side is something we do on a regular basis, several times a day, whenever we read anything. Could be in a newspaper, could be a receipt, could be if you look at social media, we do that all the time. We identify information. Let's look at an example. Say, suppose we have two short articles, and say the first one says, Barack Obama has praised the importance of the invisible workers who underpin America. The second article, Mourinho has certainly fallen away if measured against direct rivals. Again, if you're a computer, all you would see is just symbols, gibberish. So the first letter of Barack Obama is B, but the computer wouldn't know what B is. It doesn't really know what a letter is. So what we're trying to do, we want to have some methods that will extract specific information, such as the topic. So the first one is politics. The second one is sport. Then sentiment. The first one is positive. We're talking about Barack Obama in positive terms, whereas the second article is in negative terms. And so we can identify the person. So the first one is Barack Obama and Mourinho. So we have some structure. And that is the first step in natural language processing and anything related to GenAI when it comes to text. But not only text, images would, in a way, loosely speaking, function in a similar way. So why is this important? Most of the information, especially in the world, when it comes to human societies, is available in natural languages. So we have Facebook posts, tweets, blogs, we have books, etc. And they're not structured, but we can't query any type of natural language to extract any information. So if we have, again, something like that to document, and I would want to query so that I get all the negative sports articles about Mourinho. Again, computer wouldn't be able to do anything, because all this is just dots on a computer screen, or just ASCII symbols, just symbols that are totally meaningless. But if I manage to summarize the information, to extract the underlying structure, then I could, for example, use a basic SQL query or any other type of query, structured query, when I can identify and define specific parameters to then get exactly what I get. And so in this case, I would identify all the articles like the second article. So why is this difficult? And that is one of the main issues. So you probably have heard of the ChatGPT, that in some cases it hallucinates because language is really ambiguous. So if you look at some sentences, these sentences, if you think of it, they can be interpreted in different ways. But then also there are new words that have been invented, and they're being invented on a regular basis. So we have unfriend, retweet, bromance, etc. And that they come mainly from social media interactions. But then words can also change meaning. And finally, we also have non-standard English, like see you tomorrow, bye for now, and you taught us too. So and ASCII keywords, etc. So it's a very, very dynamic area. So, and that why it makes it very complicated. And so if you do a word cloud of people or the type of language used in Facebook, you see that depending on the age, the words differ by a great deal. And so also, and not just age, but could be the personality, and that is actually it raises loads of challenges, but also lots of opportunities, because based on the type of words that a population, some people are using, then we can actually identify whether the majority are extroverts, introverts, so personalities, traits, or age range, etc. And that's particularly useful for market segmentation. But in general, when it comes really to the understanding of language, these create loads of issues. So what happens then within the any system? And I am and this is also the base, as I said, of any generative artificial intelligence technique. So we want to find a structure, and in order to find a structure, we need to find a hierarchical structure. And so what we have four main categories, and these include pre-processing. So if I am scraping the web, if I'm looking at blogs, if I'm looking at social media, what I will end up with is a lot of rubbish, a lot of, for example, HTML tags and other things that I don't need. I just need the text, for example. So if I do anything related to health, and for example, I do information extraction from large medical documents, articles, and patient notes, I don't want to keep everything. I just want to identify the specific areas I want to concentrate on. And pre-processing tends to be quite demanding, especially when it comes to large quantities of data. And then the pre-processing also includes the identification of sentences. So we want to split sentences, and also tokenization. I will explain this in more details. Then once I got the pre-processing out of the way, I can start looking at the actual structure. So we have the syntax. So we have the part of speech tagging and syntactic parsing. I will explain this in more details, but I'm looking at the role of every single word. And then the next step is really trying to understand. So the syntactic bit is really understanding the syntax related to a sentence or a speech or audio. Semantic is the next step, is trying to attach a meaning. So I, in very loose terms, because it's still quite a bit of a distance from a full understanding, but at least we can carry out named entity recognition, so identify whether this concept refers to a person, to a building, to nature, etc. And then finally, we have the extraction. So that is the sentiment analysis, we document classification, etc. So let's look at the pre-processing task. So first of all, we want to split all the sentences. So we have, say, 2 sentences like this, and the next step will be to break it into 2 different in these two different sentences. Then the next step is, so we have identified sentences, which is the first step. Remember that we are at first, a system wouldn't know what it's doing. It wouldn't know what a word is, what a sentence is. But now we have identified all the different sentences. It's an easy problem. Now, the next bit is tokenization. The tokenization is about the identification of words. So after the text has been split into sentences, each sentence is split into letters. And it's easy for European languages because we have a space between two words. For other languages that don't use special character delimiters, like a white space, is much, much more difficult. So it's a very difficult problem for Chinese and Japanese. And it's not a coincidence that many of the ChatGPT techniques are based on English, or at least on European languages, because they are easier to not interpret, but to pre-process for certain. Now, we have words. Now, the words need to be put into a specific row. So we have the syntax. So we have this POS, part of speech tagging. So every word will be tagged with a specific syntactic, some syntactic information. So suppose we have this sentence, we have the POS tagger, and so what you will see that every single letter has a new some symbols, some new acronyms attached to it, and every single acronym refers to a specific syntactic role. So anything, for example, if you look at is, so he is, so is, we have VB and then Z. VB refers to verb, and Z stands for third person, and so on and so forth. I won't go into details, but it's a code. We are coding every single syntactic role related to each word. And so it could be plural, could be singular, could be past, could be present, etc. So it is not straightforward at all. So if you look at visiting relatives can be boring, it can be interpreted in two different ways. And so it could be that the act of visiting some of the relatives is actually boring, or that the relatives visiting you are boring. But depending on how you interpret the visiting bit, the attribute, you might interpret the sentence in two different ways. So we are starting to face ambiguity here, and so it can be difficult to due to the language
ambiguity.
Most of the times this is used using machine learning, and that's why, as I said earlier on, when we're looking at some of the coding, it might take quite some time, because a lot of these processes are based on, for example, neural networks and specific models that take quite some time to train. So it might be quite slow. So it's some of the techniques can also be used to understand the structure of a sentence. In particular, we can use this the structure that can be extracted from the POS tagger can be used to understand what a sentence refers to. So if you look at the boy saw the man with a telescope, you might wonder whether the boy actually saw the man using a telescope, or the boy used a man that was using a telescope. So based on the structure itself, again, I won't go into details, the system could actually decide, and sometimes the decision might not be what you expect, but in some cases it will correctly identify what you mean by looking at the structure of the sentence. And that's something we would do. And so it would be the second case, that is a boy actually, so a man using a telescope. Let me check the Q&A. Oh, okay, yeah. Yes, I think it's being recorded. So, sentiment analysis is a you've heard of sentiment analysis before. It's widely used in marketing, in business analytics, and other in a variety of contexts to try to understand the opinion, how people are talking about a brand, are talking about an event, etc. And for example, when we're talking about movies, is it positive or negative? Or what do people think about the new iPhone? And what do people think about a candidate? And the clear benefit is that we can mine loads of social platforms, blogs, and so we can gather loads and loads of information. And that is what many companies do. When we talk about politics, the opinion extraction tools will continuously identify trends and patterns related to how people talk about specific candidates. So, and that is a very and it's usually based. So the most basic type of sentiment analysis is based on keywords. So if I look at the first one, this is so cute, a great app for little ones. It's clearly positive because we got cute, great, and that is associated with a positive attitude. Whereas we have hate, I hate this app, and that's negative because hate is associated with negative opinion. Or this app is so slow, and then negative. Or oh, my little grandson loves this app. Loves is associated with positive. But sarcasm is a massive issue. So if you look at, oh yeah, this movie was totally great. So you can understand here that this person was sarcastic. So what he or she means is something completely different from what you are reading. So that is it's potentially a very complex problem. Now, how do we address this? And then again, I will go through the main techniques applicable to these areas, and then they've been used also for GenAI. So one of the most basic techniques is neural networks. Neural networks, as the word, as the title, as the definition suggests, is based on the on how, or at least how people think the neurons in our brain work. And they're very, very simple entities. So if you look at the right-hand side, we have our neuron, we have inputs. And when we talk about inputs, we always talk about numbers. So all these x0, x1, x2 are just numbers. 1, 3, 1.5. And then we have also a weight. This little weight is, think of it as how important you think that input is going to be. So if it's very high, it will have a stronger value. And if it's very low, the value of, say, x2 will be dampened down. Then we combine this, and in a nutshell, neural networks are based on multiplication, addition of these values. They are fairly simple. We have, as you can see, the different structure. We might have some hidden layers, but the structure itself is fairly simple. There are some issues related to neural networks, because what we want to do, and what we want to replicate is the learning process. The learning comes from the trial and error process based on the neural network. We have an input, we have the output, and all these little connections. Let me just get let me just laser point. So if we have all these little connections, they are associated with this weight W. So these connections might need to be stronger or weaker for a specific setting. And so the learning process, what it does is just regulates these little W's, these little weights. So we need to retune the neural network every time until these values are appropriate. The simplest neural network is a feed-forward neural network, and that is because the information goes from only in one direction. So it goes from the input. Suppose we want to distinguish between basketball players and ballerinas. We have three features of three parameters. We have height, weight, and gender. And all these are fed into the different neurons, and then all these numerical values propagate to all the neurons in the different stages, and it will get to the output, and that is whether based on the height and weight or gender of a person, whether that is likely to be a basketball player or ballerina. So now that is very basic. You can still use it. You can still get very good results. You can get really, really good results in some in a variety of situations or contexts, but there are better models. And one of them is convolutional neural networks. And assume that we are looking at images. Convolution, and that's not a case, actually. It's not just coincidental. In fact, convolutional neural networks they're based on how the visual cortex in our brain works. It's one of the few areas of the brain that some of the scientists managed to replicate automatically. And because it's relatively well understood, so the convolutional neural networks are actually very good. So we have pixels, so we have images. So, and consider two cases. The first one is the feed-forward neural network, just using new neurons. So we have a ballerina, and so every single pixel will be fed into each of the neurons. Okay, and every single of these lines will have a weight. This weight will need to be trained, will need to change accordingly, so that when we have a picture, the neural network will identify whether that is a ballerina or a basketball player. But if we do some simple arithmetic, so if we have an image 32 by 32 pixels, which is quite small, and we need to compute in total over 2,000 weights, which is it's not a massive number, especially when it comes to computers, but still, it's not negligible. But then if you consider more standard images, so we have 200 by 200, now we are increasing the number, we're getting to 80,000 weights. So if the training is very long, so if you have loads of images that we can use to get to train the system, every time for every single image, we would need to we need to understand the 80,000 weight values. So the convolutional neural networks is different, because we are, so effectively, what well, in very intuitive terms, what we do, we just focus on different images or different regions of an image. And so what it does, the convolutional neural networks, basically is slices the image, and we'll look at edges, we'll look at other parts of the image, and by doing so, the training process is much easier and much more efficient, and it's actually very, very accurate. Another type of neural network that is widely used in NLP and in GenAI is recurrent neural networks. In the traditional artificial neural networks, we have a flow. So we have an input, we got something here, here we only have one neuron, and then we get the output. So in this case, it's ballerina. In recurrent neural, so the flow is determined, is well determined, is going from input to output. But in recurrent neural networks, we have some sort of cycles within the neural networks. So, and the current input, it can be influenced by previous input. So suppose we had the previous input, we had a basketball player, and so, but it's not just, so the next the current input is not just an isolated instance. The previous one will influence the current input. So it's based on some techniques that can help with the training process. Another term that is widely used is deep learning. What does it mean in very simple terms? So it's fairly straightforward. So what we have here, we have loads of layers. So we have if you think of the general feed-forward neural network, we have some layers. And the idea is that if you add more and more of these hidden layers, the more precise it will become. But it will become also very computationally demanding. So deep learning is because the network becomes deep. We have a large number of all these layers. And with all these extra layers, we also have a large amount of weight to understand and to assess. So why do we have deep learning? Why has it become so relevant? First of all, because we have better and faster hardware, so we tend to use GPUs to train our models, but also better and larger volumes of data. The first one is not causing massive issues, although we know that at global level the creation of chips is becoming more and more difficult. But there are also some issues related to the specific electronic chips, because if you want to add more and more components, more and more connections, then we need to go smaller and smaller, and we get to a point where that is no longer possible. And on the other hand, we have data. We create large quantities of data. Data is created on a daily basis, but this data needs to be stored, needs to be pre-processed, and which requires a lot of resources. And so there are specific companies doing so, but the data is not available. It's just used for those companies. So the models used to train ChatGPT is it's not, yes, it's open source up to a certain point. Some of the actual data is not usable. And so, in fact, all this started in 2009, and artificial intelligence had gone through different winters and summers, so ups and downs, really. And so there was this large database of images, and a team in 2011, led by Jeffrey Hinton, presented AlexNet, a convolutional neural network trained on the ImageNet database. And it was, the training process took between 5 and 6 days, but the results were groundbreaking, 10% improvement. Right. Let's look at an example, then I'll show you some of the coding examples. So, and that's actually a real example. So if you look at this, you can actually go to this link and you can actually see for yourself. So let's suppose I want to train a neural network to create some text based on Leo Tolstoy's War and Peace. Each iteration will adjust the weights. So remember, is the connections between every single neuron to better predict the next letter in a sentence. Remember, the computer doesn't know anything at all. It doesn't know what or who Leo Tolstoy was, what War and Peace is, etc. Doesn't know anything. And so after training, the neural network can produce Tolstoy-like novels. Okay, so after 100 iterations, which is virtually nothing, we'll get just gibberish, okay? But we can start seeing spaces and some commas, okay? So the model has learned that there will be letters, and then there will be Y spaces, and there will be some punctuations, such as commas. And then after 300 iterations, it's still nonsense, but we start getting some English words. Okay. Then after 500 iterations, we get some more English like words, but there are still many errors. Then we have 700 iterations. It looks like much more like English text. And then we have 2000 iterations. So most words are properly spelled, but the content doesn't make any sense. But at least from a total gibberish, we are now in a position of understanding, of seeing some English words. But the system is still not fully trained, and so it won't be able to predict the best next word or next words. So the text won't make any sense. So let's look at some examples. Let me just go to my where is it? Let me just, I try to get rid, here we are. Can I just, sorry, just here we are. That helps. So let's look at some very simple examples, really simple examples, and then I can release all this code, and you can actually run it using Colab. But as I said, some of these models, and it's based on Python, might take quite some time to run. So I didn't want to do it live, because it would last quite a bit of time. And so we use one of the libraries in Python it can be used quite extensively. One of the most basic and most widely used libraries in Python for natural language processing is called NLTK. It stands for Natural Language Toolkit. So we need to download all the different models. And so I suppose we have an input string that is a copy and paste from some BBC News article, and so that we have a string, and that is computer now. All this is a string, so just a sequence of characters. So the first step is to split it into sentences, as you can see. So now we have the different sentences. And then we have tokenization. So we split the text into words. Note we also get punctuation. So here we have a comma and we have a full stop. So that will be part of the tokenization process. But still, the system doesn't know anything at all about these words, and they know they are isolated tokens, but pretty much it. The next step is to include the syntax, to understand the syntax of these tokens. So we need to download a specific model, and based on the name of this model, Perceptron, I can tell you that there is some neural networks involved. And if we use, if we invoke the POS tagging, define as POS tag with the tokenized string, so once the string is being tokenized, then it will produce the POS tagging. If you remember, that is what we got from the slides. Depending on what the symbols are, we can we know what how the system interpreted or guessed the corresponding syntactic role. So for tarmac, we have noun, and so on and so forth. Now, some other techniques that are used, and in some cases they're done automatically, but it's trying to identify the structure. So here we only have the syntactic role of the words, but now we really want to know the structure of the hierarchical structure of the sentence. And so, although it's not particularly it's visually helpful, but we have this tree. If you remember on the slides, we had the boy saw a man with a telescope sentence, and so we have something like this, and then a specific sentence. So it will be visualized accordingly based on the tree structure. There are better ways. So Colab is not great at visualizing this. It's pretty much like ASCII characters, but there are other techniques, other tools that you can use to visualize that. It's not just about visualization, it's about the interpretation of the roles. So let's look at another example. Let me just drag it down. So the second example, so it's similar, but with some differences. Now we have a larger set of libraries we need to download. Again, this might take quite some time if you run it. So suppose the text data, so our string is, "I hope you are enjoying this seminar. NLTK is an excellent NLP library for Python, full stop." So when it comes to any textual analysis, what we don't want, we don't want duplication. A simple example, if I say woman or women, we are referring to the same concept. Woman is singular, women is plural. If I say bus or buses, the same concept, but one is plural, one is singular. So the first step is to remove all the capital letters. So we use we lower the text, and so as you can see, the output is really, so everything is in small letters, and that is to make sure we normalize it. I've done this extra step, but in many cases it's not necessary. It's done automatically. Well, first of all, let me just Q&A. Okay, sorry, I think I should have answered this question earlier on. The input of the hidden layers is, let me just go back to let me just go back to the picture of the neural network. Where is it? No, it's further down. Further down. Sorry, I'll just find it. Where is it? Okay, hold on. Just give me a second. There we are. So if you look at this image, so the hidden, that is, in this case, we only have one hidden layer. So we have everything on the right will be fed, as you can see, into each node in the hidden layer, and so on and so forth. So if you look at something more complicated here, this here, say the input layer, but let's look at the first hidden layer. Everything will be, so the output of this node will go into all the other neurons in the next layer. And so as you can see, then the second, again, will be, the output will be fed into the first one, second one, third one, and so on. And so will the same for the other. So it's very, so it goes from left to right for usual artificial neural networks. Okay, hope that answered the question. And so now we're doing tokenization, and we're also aware of the time. So we also want to remove stop words, and stop words is everything that is not really what is useful. So this, for example, or A or N, they're not really useful. They're not telling us a lot. So we don't need those words, because if we keep those words, we would need to analyze them. The system would need to analyze them, but they're not really giving us a lot of extra information. So we can remove some words, so we can decrease the level of complexity. And then we have the lemmatization. And lemmatization and stemming, what they do, they standardize all the different words even more. And in particular, more than the stemmer, the lemmatizer is even better example. So we have buses, wives, rocks, women, classes. If you lemmatize it, these words, what you have in singular form: bus, wife, rock, woman, class. It doesn't get it right all the time, but so if we are extracting information, so we don't want to distinguish between maybe women and woman, because they refer to the same concept, the same human with specific attributes. So we don't want to have two separate entities. So the same for buses, the same for wives, etc. So and that type of standardization helps us with the analysis. And then we can also look at n-grams. N-grams was it was a project, part of the project introduced by Google. And so what we are doing here, we are looking at sequential words. So if I say n-grams, and the n gives us the number of sequential words. Here I'm saying 3. So that means I take the first 3 letters, I hope you, and then I move by 1, and then you say hope you are, and so on and so forth. That is useful, especially when it comes to co-occurrence. And you can actually download n-grams, different n-grams, 2 grams, 3 grams, 4 grams, etc. And so, and that is, so these n-grams, especially when are collected over large quantities of data, can help us to the prediction of what to expect. So if you say, for example, good night, or, well, let me just, for example, NLP library, okay, that's even better. So NLP and library are likely to occur together, and that is determined by looking at how many times in text they do occur together. And so if it's very high, the number is very high, you can assume that NLP and library should be kept together. And so that is another way to integrate textual information. I won't go into all the details here, but what we are doing here in the next few coding lines is we use some mathematics to understand similarity. So that is a good example. So suppose I want to understand the similar words compared to apple. So there are some word to vec, and that means word to vectors. So we look. So if you consider a space of words, a textual space, what we can see, we can find every single word in a specific space. So one example might be the space of all the documents in the world, and then all the documents contain a specific word, and we'll have a specific position in this space. And so what we'll have, based on these mathematical attributes, we can find what the similar concept. They sit close to apple in this space. Not surprisingly, apples is quite similar, although as you can see, it says the similarities kind of 72%. And you would say, well, apple and apples, what do you mean? You know, if I'm referring to apple as the fruit, apples is just the plural. So, or is it? Am I talking about the brand and apple? But still, you might find some inconsistencies, and all these inconsistencies, based on the ambiguity of language, can be seen in the more complex models, such as ChatGPT. The final one.
I am so sorry to interrupt you, Professor.
Yeah.
But we are actually, running quite short in time, as we have a scheduled event elsewhere.
Yeah.
I do understand, the topics are quite interesting and we can go in depth about it, definitely.
Yes,
but
I actually
yeah.
finished. Sorry, I can talk. But the next exercise is not mine. It's something that I would say you can try yourself, and happy to share all these exercises. So I've stopped it. And is there any questions or anything else?
So we are open to questions. If anyone has any questions, we'd be happy to answer them. Professor Marcelo would definitely like to answer those for us.
Yeah, I mean, I've got one from Joseph. Yes, I'm happy to share the links to the Colab netbook. Absolutely, there are plenty of links and tools in Colab. But yeah, absolutely, and I'm happy for you to share my slides or anything.
That has definitely helped. So I think I had seen a question earlier, right? Like I believe it was that if someone is coming from a non-tech background, and this is something that we also wanted to ask in the beginning, how easy would it be for them to, start with this particular journey, or how difficult would it be for them to start with this journey?
It's not straightforward. So there is a lot of, in order to understand these techniques, it's important to know at least some of the basic tools. So some of the topics that I mentioned, but it doesn't need to be a very technical knowledge, but at least know how a computer would interpret text. For example, we are talking about text. And that will help to also understand the limitations, because there are plenty of limitations. But it's also trying to play with the code. If if people are interested, there's plenty of material out there that can play. Some of it is very technical, As I said, some of it is more approachable, but
Okay.
yeah, that's the easy answer in a way.
Sure. So we're still happy to answer any questions that people may have. Let me just see. I see that there are some mentions. Yeah. So if you can, can we collab notebook? So
Yeah, I will.
yeah. So people have asked for the link for the collab notebook. I
Yes.
see. We didn't go over them fully. Some have asked for the links. Is there a place for knowledge representation and semantics when it comes to generative AI?
When we talk about knowledge representation, anything that's semantically, well, we're talking about semantics web. There is a place, but it's not fully developed.
Okay.
There should be, and there must be, because we can see loads of limitations. You see, in some case, for example, ChatGPT, you can get great things, but then if you want to use it properly, you need to pay for it in some cases. So there is they're trying to sell your product. So in some cases, they don't really tell you the real limitations. And the real limitations is that, yeah, it looks great, but it's still far from being fully functional, fully usable. It does pretty much good job, but there are still quite a few limitations. And for example, we're talking about hallucination. That's a fancy word that has been introduced. Correct. What it means that it just gets things wrong, or it misses the point. But yeah, I mean, it's there is a need, and there will be in fact, the next stage of artificial intelligence research really focuses on the semantics. You're trying to make sure computers and systems can actually attempt to understand rather than process.
Okay. Now, I think there are a few more questions, but these are there are mainly two questions that I can see. One is for the link that you have mentioned for the Colab platform. So I'd recommend if you can share that meanwhile on the chat itself, right? That would definitely be helpful. And the second question that I see at this point, I believe that is related to the program. So I'll take care of it. And we do have one more question from Rajesh. That is there any point in sticking to the basics when there are new no code tools?
No code tools. I don't know, to be honest. I never used them, but they tend to be black box in some cases. So you don't really know. I've seen some. I don't know, never used them, and I don't know how good they are. But I'm always suspicious. I mean, personally, I want to know how it works. So I guess it's going to be quite complicated. In some cases, even learning a bit of coding is always beneficial, and it's not that complicated. That's what sometimes it's easier than actually trying to drag boxes onto the screen and understand the connections.
Correct. Plus, to add to the same answer, right? I believe that, at this point, when we actually have even generative AI creating codes for us, we still need people who are going to, go ahead and understand whether that code is 100% correct or not, right? Because even the best of coders or programmers, they do make some mistakes sometimes in the logic, right? So that does need supervision, does need a second eye or a third eye to go over and identify and then, assist in the process of making something better. So the same thing applies in anything that we are creating, no matter whether it's a no code thing that has been started, whether it's a drag and drop box that has started. And these are tools that we have actually created for children, primarily so that we can get them to, be interested in the STEM world itself. Because anything that we look at right now, STEM is the pillar, the foundation for it. So if the foundation is laid down from the very beginning, the logic behind things are laid down pretty straightforward in the beginning itself, that would generate their interest, the interest of our children, the interest of our communities in this vertical itself. And that is basically the idea, right? And maybe a millennia from now, we would be able to go ahead and do star travels based on these ideas itself. The requirement is that we need an entirely scientific world, and that is something that we need to work on right now, which is why these tools are there to assist us create those environment around us for our future generations. I hope this does add well to the answer, Professor Marcelo.
Yeah, no. Yeah, absolutely.
Thank you.
I do have a question. I'm trying to share the Colab, well,
Okay.
the Python, but I can't send it. I don't know
Mhm.
how, to be honest.
So, are you able to see the chat option?
Yes,
Okay. Can you share it with me? Maybe I could share it with everyone.
I can. Let me see. Screen share. And there you are. So that's what oh, where is it? Hold on. Yeah, that's what I see.
Mm-hmm.
And I selected everyone, but then I don't know. I can, if I do that.
Can you actually copy the link from over here?
Oh,
Like,
okay.
yeah.
Okay, I'll do that. I'll do that. Okay, let me just stop sharing. And so I'll do hold on. Yeah.
Sure. So you can copy and paste the link in the chat box itself, and that should be available for everyone to go through. I believe at this point we have answered all the major questions that we have so far. The next ones that we have is actually coming through the program. So, Professor, if you want, you can actually drop down once you have shared the Colab link with everyone. If the link is not shared in the meanwhile, or if there are any challenges that we face, what we will ensure is that we can reach out to everyone who's interested. Yeah, so the link has been shared by Professor Marcelo.
Yeah, just one, and now I'll keep sharing them. Sorry, I'm getting there.
No worries. So what we can do is we can create a library meanwhile, and anyone who's interested, you can reach out to me on this email ID. I'm just sharing that in the chat itself. So if you want, you can also reach out to me on this email ID, and the library that is created will share it with you as well. Now, with that being said, Professor, once you feel comfortable, you can drop off if you want. Now, I'd like to take this opportunity to, answer the questions related to the upgrades platform, program that we have actually launched. This is the Advanced Certificate Program in Generative AI. Now, I do hope my screen is visible before we move forward.
Okay, super. Okay, so thank you very much, and I hope you enjoy the rest of your day or evening.
Sure. Thank you so much,
Okay,
Professor.
thank you. Bye-bye.
Bye-bye. Have a great day ahead. Now, with that being said, I believe we have taken care of everything. Just give me a second. Anyone on the line who has any particular questions related to the program, please feel free to ask me and, jot down your questions on the platform at any given point. Now, I hope my screen is visible, and you can see that this is the advanced certificate program that UpGrad has actually brought into the picture. This is a 4-month long program, and the idea behind this is that as we move forward, all of our learners are able to go ahead and understand the generative AI concepts. Now, we have seen that ever since ChatGPT was launched, the entire machine learning concept or the machine learning world has taken a sudden leap forward. It's not just that we have generative AI, just ChatGPT that is a form of generative AI. There are multiple more. You have Midjourney, you have Bard, and many other individual programs that are coming out day on day. And there are hundreds of these depending on the modes and the outcome that you want. Now, the idea behind this particular program, the Advanced Certificate Program in Generative AI, is to ensure that even if someone is coming from a non-technical background, or even if they're coming from a technical background, what we can do is we can help them understand the basic Python programming with our complementary Python bootcamp program, and ensure that they understand the basics first. Then they go ahead and learn how they can create their own platforms with the availability of these large language modules that Professor mentioned. And these would be majorly the open source modules that you'd be using. Now, if my screen is visible, I would like to see if I have any questions at this point. I'm sorry. Sure. So Ola, we will definitely create a collab of all the links, and you can reach out to me on my email ID asking for the link, and I'll share it with anyone who reaches out to me. Now, that being said, I would like to mention that this program is for a time frame of 4 months. You would be going ahead learning about the basics. Plus, you would also be creating your own platforms with the help of your subject matter experts and your industry experts who are going to ensure that you go ahead and learn more of these concepts in a timely manner. The idea behind it is that the world has become a lot more competitive, and your peers are going to get a very good competitive edge with this. So we want you to be updated, we want you to be upskilled with these updates that are coming your way. Now, there's something new that we have done in our cohorts with this with the generative AI program, and that is we have a live project based classroom. When I say we have a live project based classroom, all the creation of these platforms would be done on the live session itself. So you will have your subject matter expert. Now, basically, there are multiple subject matter experts depending on the module that are being covered. So let's say, for example, if we are working on something where we have, so the very first project that we have is actually creating your interview genie, which is we create an interview AI which asks you question, and then based on the answer that you provide, they give a feedback to the employer on the parameters that the employer is looking out for, and then the employer can make a well-informed decision on who may be the best candidate to hire. Now, this is a situation that employers face most of the time, and this is something that will help you create in a live project-based classroom environment. So basically, while you're in the session, you would be creating this along with your tutor, and any objection that you face, any challenge that you face, it could be unique to you, it could be unique to your particular cohort, that would be raised on that time itself and would be responded to. In addition to that, the general idea is that while you're creating these, there are going to be multiple doubts that will come, and we want those to be shared with everyone. These cannot be scripted down in a format and shared with every cohort that moves forward. So we want to share this, we want to keep this updated so that each and every of our learner are able to go ahead and understand these. So far, if there are any questions, I'd like to address that. Oh, so Adam, I have shared my email address. Let me just reshare it again. It's akashkumar.jha@upgrad.com. I've mentioned that again in the chat. Now, when it comes to the delivery of the program, there are going to be multiple, platforms. Basically, you'll be doing the entire learning on Upgrad's platforms itself. That is the primary thing. The second thing is that there are going to be multiple GenAI tools that would be used. When I say GenAI tools, this would be ChatGPT, OpenAI. We will have Whisper API, BERT, RLHF. We will have Midjourney, DALI, and these are very, I would say, output specific language tools that you have. The general idea behind this is that if you need something that works on images, you would have to work on Midjourney or DALI. If you want something that works on the prompt text that you're providing, it would be something based on OpenAI or ChatGPT or Whisper AI. So these are the the modules that are being designed and programmed in the best way possible to ensure the efficiency of the same. At the same time, what we are going to do is everyone who has reached out for this webinar, we are going to share an email with you, and your respective academic counselors are also going to get in touch with you regarding the program itself. This is a 4-month long program. As you can see, we have a cohort that is starting on 30th of September. For all the members who are part of this webinar, plus additional 15 members, we had a list of additional 15 seats, out of which 5 have already been filled. We have 10 seats remaining for this cohort now. For these 10 additional seats, we would be providing a $500 fee waiver. Now, if you want to move forward with that, you can let your academic counselor know about it, and he will help you get the fee waiver applied in your case. With that being said, this is the general idea about the delivery of the program as visible on my screen. you can see that, as I had mentioned, the complimentary Python bootcamp program is being provided, which will help you cover the basics of the program. There's going to be a 24/7 chat support team in place for you. The average recommendation for you to study in this program is 14 to 16 hours in any given week. There are 6+ projects that would be done in a live session format. These are hands-on generative AI projects. So that means that these tools, anything that you need, right, this would be practiced in the classroom environment itself. And you will also have the outcome in the same tool itself. At the same time, these live programs are also being recorded. So in case you want to revisit the session at a future date, you can always go back and revisit the idea, revise what you had learned in that particular session. Once you have completed the program, you'll get a certificate in generative AI. Now, why upgrad certificate matters in this case is because upgrad, number one, is working globally with, like I mentioned, 3 million learners all across the globe at this point. We have our learners placed in various organizations at leadership profiles, at multiple other profiles. And the best part that helps us, right, is that we are actually providing the machine learning concepts to multiple organizations, and we have already drafted it and reached out to a number where it is quite effective, especially in the international market. So it has wide acceptance in all these organizations. Imagine two scenarios. If you are looking for joining an organization, definitely if they need you to learn this program, they'll definitely train you on that. But at the same time, if you are already skilled on the program, if you already have the certificate that they ask for, that would always go ahead, ensure that you save on your time, and at the same time you add more leverage to your favor when it comes to negotiating about your profile. So these are the opportunities that you get. In addition to this, I'm open to any questions at this point that anyone may have. So we don't have a referral code. I see a message from Adam. Okay, let me actually share that again. Adam, you are correct. That was not to everyone. Let me reshare the email ID. So I've reshared the email ID. My apologies about that. It is to everyone now. Maria, we will have someone that will reach out to you. Referral codes are something that can only be provided by an existing learner, and they can assist you in going ahead and enrolling and getting the benefits if you want to move forward with the program. Definitely, your academic counselor will reach out to you and ensure that they help you in the best way possible. Any other questions that people may have, I'm open to that at this point. Now, if you look at the different tools that are being used, you'll see that it is ChatGPT, Midjourney, you have Hugging Face, you have DALI, you have OpenAI. Similarly, there are multiple other platforms which are used for different reasons and different outputs. When it comes to the faculty member, Gopal, you have subject matter experts from various organizations. Now, when I say subject matter experts, these include people like Behzad Ahmadi, who is actually a machine learning engineer, and he is currently working. He's actually the machine learning head at Meta. He has about 2 decades worth of experience. He has completed his MTech and has done a PhD from Jersey Institute in Data Science and Machine Learning. We have Georgios Ozonius, who is actually the head of AI research at Atlas AI. These are some of the profiles that you can actually look at. These are available on Upgrad's website itself. You can learn more about them. You can go on, visit our website. And at the same time, any question that you have, you can always ask us about it. The general idea is that the subject matter experts that you see over here are a few, and we actually have multiple subject matter experts who hold a similar level of experience and background and can help you in your understanding. Their sessions are scheduled as per the module that is to be covered. I hope this has answered your question. Wonderful. Now, excuse me. Since we have this cohort that is starting from 30th of September, and if any one of you is interested, you can reach out to us. You have my email ID. You can reach out to my admissions team. The email ID for admissions team, I'm writing that down at this point. You can reach out to the admissions team as well, and they will help you reach out to your academic counselor if needed. Or if you want, you can directly reach out to me and I'll help you with the same steps required. With that being said, we have our cohort starting on 30th of September. And if you do wish to join the same, like I mentioned, there's a $500 fee waiver that would be provided to you if you enroll in this program. The launch fee of this particular program is at 2,500 US dollars. And with the fee waiver, it'll come down to 2,000 US dollars for this particular program. I'm open to any questions at this point if anyone has one. So Maria, for you guys, the fee would be at 2,000 US dollars with the fee waiver already applied. So generally, when you look at the referral fee, uh, for Euro, I'll actually let the academic counselor for your region reach out to you. It should be a little less than 2,000 euros, but I would ask the academic counselor to reach out to you for that. I hope this answers your question. Sure. Now, if at this point anyone has any questions or you want to go through the brochure, it is available on our website itself. Additionally, what we'll do is we'll ask your respective academic counselors to reach out to you, and they'll do the needful in the respective time zones and assist you with the next steps. With that being said, I thank you all for joining the session. It has been a wonderful session, and I really appreciate you coming on board. I look forward towards you having you in the program and taking the next steps going forward. Thank you so much for that.